Hello, this is Rich Scott working on his second video. Uh, this will be estimating existing sprinkler design. So it's not cost estimating a sprinkler system, but it is looking at an existing sprinkler system that's in place and trying to determine what the design of the system is. It's as if you've gone out to a site and there are no placards in place, there are no sprinkler plans in place, and through a little investigative work, you're going to try to determine what the design of the sprinkler system is. It's really dedicated to insurance engineers, engineers who are going out to estimate a system, authority having jurisdictions. And as I said, the point of it is to walk out of the building with some idea as to what the sprinkler system is and whether it's adequate for the occupancy. This will be a multi-purpose, multi-part video. I want to try to keep these short. My first video ran about 30 minutes, which is far too long. I'm a retired engineer, worked for 40 plus years in the industry. I wish I was out at a site to show you how to do this, to visually be at a site and take you through this, the process. I don't have access to facilities anymore, but I think we can get a pretty good idea of how this works just by doing it through these presentations. So first part will be to sketch out a sprinkler system. Okay, before we get started, let's just use the disclaimer here to entertain the idea that this is nothing but entertainment. It's my opinion only. If you are looking for clarification on codes and standards, seek out a trusted professional or NFPA for further information. So before we can estimate what sprinkler system is doing, we've got to be able to sketch it out to get a sense of what's up there. And to do that, we're going to need to look at the configuration of the piping, which I'll go into in a little bit more detail. We'll also need the correct pipe size. It's not as hard as it may seem, but and I'll give you some hints as to how to come up with what might be the correct pipe size. We're going to need sprinkler and branch line spacing. Very important. The spacing between sprinkler heads, the spacing between branching lines says a lot about the sprinkler design. And I'll get that in subsequent videos. For now, I'm just going to say that it's important that we have that information. Sprinkler head information. Go into the spare cabinet. Maybe you can grab some information on that. It's going to be really important because it says a lot about how the sprinkler system is designed. Water supply information, we can get that through a call. We're also going to look at the two-inch drain test. Not the best method to come up with an estimate, but when that's all you have, that's all you have. And finally, underground line to the street. We want to know the size of the pipe and the distance to the street from the building and the age of the building or installation, which is really important because the age of the building and the installation tells us loads about when the sprinkler system was designed, and it gives us context to make decisions about how the system was constructed, because 1960s building is not going to have an ESFR system, so we can rule things like that out. And it really does simplify the process by knowing the age of the building or the installation. Now, sketching out a sprinkler system at first may seem to be a daunting task, and in some cases it is. So there'll be your easy situations where you've got low ceilings, ceilings are painted white, there's very good lighting, might be a pipe schedule system, which tells you a lot about the pipe size. And those are the easy systems to do, but there's some real challenging systems out there. You might go out and the roof height might be 40 feet. Well, even I've done hundreds and hundreds of sketches. And once you're up looking at stuff that's 40 feet off the ground, you're just making your best guess. I mean, you really are. At 40 feet, things get really challenging too. Is that a 2? Is that a 2.5 inch line? You just don't know. It's hard. Dark ceilings. Again, That's why I thought about doing the video. In a lot of cases, you look up and the ceilings are so dark, or the lights blind you that it's hard to see. So there will be challenges where trying to obtain information on the system is just not going to be an easy task. There are other challenges. Forklifts. You're doing this in a industrial environment, and forklifts will be zipping around. The other challenge of safety challenge of forklifts is you getting reckless and possibly trying to get in a forklift to go up to get a view of a sprinkler head, for instance. I have done that. I'm not particularly happy or proud that I did it. Where someone forklifted me up to, I stood on a pallet and they forklifted me up to the sprinkler head so I could grab some information, because there were no spare heads, and that's just really an unsafe thing to do. So I would say safety could be a real issue. There's a time element to. Sometimes you've got a customer just breathing down your neck, and is giving you, minimal amount of time to grab this information. So it's helpful to be able to work quickly on this. And then lack of critical components, as I said before, if there aren't spare heads, it's going to make it more difficult. It's just a real challenge to make a determination when you don't see a sprinkler head. So those are the challenges that we're faced. I want to talk about configurations of system before I go into any more detail. And I know what you're saying. Say, come on, could you not have grabbed a professional looking drawing off of the internet and just snagged it and placed it there? And I did this for a purpose, or I think I did it for a purpose, and that is, which I will explain in a few slides. But I do want to go through the different types of configurations. It's a tree system. And if we start in the lower right, there's the underground line coming into the building. We're going to be interested in the size of that line, and also the distance from the line from the building to the street. And then there's a riser with the control valve and an alarm check valve. This is a wet system for this discussion. And we're going to want to know the height from the floor to the deck one, and to the top of the cross main. You can see that cross main is a horizontal line that runs straight across. And if you look towards the continuum on that to the left, you'll see an RN, that's a riser nipple. So that tells us that from the cross main, there's a pipe that will now extend to the branches, and those branches are the vertical components that you see. And as you can see, I've kind of given the distance between branches 10 feet. You can see that on the upper left-hand corner, and you can see right next to that those cross marks are actually sprinkler lines, and they're also sprinkler heads, and they're changes in pipe size in some cases, or sprinkler heads placement. And so in this case, it's 12-foot on center spacing between heads. And you can see if you go to the last branch to the left, there's a 1-inch line, a 1-inch line, a 1 1/4, a 1 1/2, and then coming from the other side is a 1-inch line, a 1-inch line, 1 1/4, 1 1/2. And then over in the upper left-hand corner, I have a thing that's IT, and that's an inspector's test. We're going to need that. So we're going to use certain pipe sizes that we know to determine what the pipe sizes that we don't know are. So that's the tree system that you're most likely to find. Older systems, of course, will almost always be tree systems, and that's a system that you're going to find for the most part. The next system is a grid system. And if you look at the bottom of the page, just as in the tree system, you have an underground line, a riser, a feeder main. But in this case, rather than a tree, we have what we would refer to as a grid. And you'll see that there are two horizontal lines. The one at the bottom of the page would be called a near main. That's the one that's being fed off the feeder. And then the one at the top of the page is the far main. In this case, we have 16 branch lines, and those lines run vertical. You can see from near main to far main. And in this particular case, the spacing is 10 feet by 10 feet. The the branch lines are 2.5 inches. And you'll notice in the upper right-hand corner, there's a thing called an outrigger. So you can have the sprinkler heads end inside the two mains, but sometimes they'll extend outside. And when they extend outside, we refer to those as outriggers. In this case, there you can see there's two X's. Those denote sprinkler heads, and that means there's two sprinkler heads outside the main. Let's move on to the next system. The next system is a looped system. It takes components from both the tree and the grid system. Again, starts with the underground, the riser, the alarm check valve control, then the feeder main. But in this case, what we have is a loop that feeds all the branches. And if you can imagine, rather than having a cross main with a single feed running to the branches, now we've split the flow, which reduces the overall friction and allows for a more robust system. And in this case, we have a loop that runs, and also allows for flow in either direction as well. So we have this 6-inch loop that runs around, and then you have branch lines that are fed off the loop, and you can see that in this case we have you have 2-inch branch lines. Inside at the top is 4, outside is 3 sprinkler heads, and then there's 3 and 3 on the other side. But it's a system that is generally I saw for warehouse type application because of its the ability to flow water better. It's something that I didn't see much of, but it's one of the 3 big configurations. Before I get into sketching out the systems, field sketching the systems, we need some tools. So as late in my career, I was able to secure a Leica laser measuring tool. It's just a laser, made life very simple. Height, distance between branches, distance between heads, height of storage, all became simplified. I think this is the way to go nowadays, is to grab a rather inexpensive tool to really get accurate information. The way we did it in the past was to pace it out. And pacing out is, not the most accurate system in the world, but I can tell you, having paced hundreds of systems, I pretty much knew the difference between a 10-foot and a 12-foot spacing. I was pretty confident. I mean, couldn't tell you the difference between 9 feet, 6 and 10 feet. That was not within my spacing accuracy. But to pace out 10 to 12 feet, I knew what I was doing. And pacing out, or grabbing information through the laser that is accurate enough to give you head spacing, is critical. It is absolutely critical because it tells you a great deal about the system design. So I would say you need to have this in your toolkit. 1, you need to have the laser tool. 2, if you don't have that, you need to have pacing skills at a level where you can make reasonable estimates. I'll give you a great story where we had sent out a young guy, and I was on the phone with him, and he was pacing out the system, and he kept telling me that the head coverage was 7 by 8 feet. Well, it's just not the case. It can't be the case, and that was just one of those situations where, he did not have the pacing skills to do that. So very important to be able to make an accurate determination as to what the head coverage is. Okay, I told you there are a few tricks to determining pipe size. I mean, at some point you'll uh, you'll have a level of confidence if you do this enough that you can look up at the pipe and know what the pipe size is. But until that time, there's a few things you should look for. One is the inspector's test. Now, the inspector's test is generally going to be a 1-inch line. Why is that important to us? Because it's connected to the end piping, the end of a branch. And we'll be able to determine if that end line is 1 inch as well. So what we'll have is the inspector's test, 1 inch, it's connected to something, we look up, it's similar, boom, there's 1 inch. There's the first piece of the puzzle. Now on the other end, at the alarm check valve, the alarm check valve will be identified by size. So you have that piece and you can work on that piece. So you've got these two pieces at either end. No, an inspector's test doesn't necessarily have to be at the end, but for the most part, it's going to be at the end of the system for a wet system. And you'll have the inspector's test at one end, giving you one dimension. You'll have the alarm check valve giving you another size. And then sometimes you get lucky and there's actually identifying markers on piping. But at least you have two pieces of information that you can then start to work towards to determine the piping that you don't know the size of. And there's one other clue that we'll look at on the next slide. What we have in front of us is a reducer. So as I said, we look at the inspector's test, it's 1 inch. The first pipe it's connected to is 1 inch. The next pipe is 1 inch as well. And then we see this reducer here. And so we know the 1 inch is on the right-hand side. The next pipe has got to be a larger size, right? And the next size, the most likely size is the 1 1/4. And then we go along, we see that there's a reducer again, and the next pipe is a 1 1/2. And it's a really simplified way of establishing pipe size, even if you don't know what you're doing, is by using the reducer and increasing one pipe size every time you run into something like that. Why did I sketch out my system rather than just grabbing something professional looking from the internet? Because I wanted you to know that this is not a clean, perfect process. We're not looking for perfection here. And I think you'll remember those hand-drawn sketches that I provided of the different configurations. And this is the same. This is that tree system, but now I'm out in the field. And so what am I doing is, for me, I'm starting at the riser, identify the distance from the riser back out to the street, and I know the pipe size. I use my laser pointer, or there is a variety of other tricks too. If you don't have a laser pointer, you can count these CMU blocks to establish the height. There are a variety of tricks that we would use to establish what the height of the building was. And then I go to the other end of the system, to the far left there, and I start grabbing the pipe sizes from the branches. And in these particular cases, it's a 1 inch line. There's another 1 inch line. There's a 1 1/4 and a 1 1/2. And again, I'm using the inspector's test to ensure that that 1 inch line looks like the 1 inch branch, the end line. I'm using the reducers. I'm looking at the riser nipples to establish size. I'm determining that the branches are all the same. So if there's different branches, then I've got to sketch them out. But in this case, all the branches are the same. So once I have that one branch, I'm pretty much all set. While I'm over there, I'm grabbing the spacing between the branches and between the heads. Really important. It is really one of the single most important pieces of information because it really tells you a lot about the sprinkler design. So you've got to do that and you've got to be accurate in that. And then I just start to work backwards. Using the reducers, I grab there's 10 foot of 2, then there's 2 1/2, and then there's 3, and I just work my way backwards along that cross main until I've got a system. Now, I've calculated, hundreds of sprinkler systems. We used to have a coded system called Walsh back in the 80s. Then we went to a graphical system in about 2000, and 15 to 20 minutes, I can punch this into a system and grab some numbers. But even without that, one other piece of information, I've also gone um, into the cabinet, and I've pulled a head that's a K 5.6 head at 165 degrees. And so in this particular case, I've also grabbed the 2-inch strain test, and it's 75/65. So right now, I pretty much make a determination as to what's going on with this system. It's an ordinary hazard system, probably, who knows, designed in the 60s. It's got 75/65 2-inch strain test, pretty good. 6-inch line is not a very big line, running 300 feet. This is going to put out a ordinary hazard density, 0.2, 0.25, somewhere in that vicinity. It's as long as I'm going to a machine shop or something like that, it's going to be perfectly adequate. And if I'm looking at any kind of significant storage, the sprinkler system is just not going to work. So without even doing calculations, I got a pretty fair bet. But we'll go into that in a later presentation. Now it turns out the grid sketch is even easier. So what we're going to do is, again, get all that underground information, the riser height, the alarm check valve size, the control valve, et cetera, the size of the feed to the near main. And then we're going to grab the dimensions of the near main and the far main. Usually the near main is going to be one size larger than the far main. I just made them the same size just for ease of purpose here. And I'm going to grab if there's a riser nipple, I'll grab that information. And what I'm going to do is just count the number of branch lines. I have 16 branch lines and they're 10 feet on center. Got that piece of information. I have 12 heads on the branch and 10 feet on center and a 2.5-inch line. I'll grab that information as well. I go to the cabinet and there's a K14 head there. Now, if you recall on our sketch outside, as I said on the loop, I have to sketch the entire branch line. On this thing, I didn't even bother including the heads that were outside the near and far main. Those called outriggers. So if there's like 2 heads that are outside the near and far branch line, then I'm not going to include them in the sketch of the calculations. They're probably not going to be germane to the situation. However, if there are 4 or more outrigger heads, then I'm kind of scratching my head as to why someone did something like that. And now I've got to include that design as well because it may come into play. I really shouldn't have that number, but I suppose there could be circumstances. I just did not run into that. Usually there were a minimal number of outrigger sprinkler heads, those heads outside the grid system. So I leave the loop system to you to try to figure that out. This is the first in a series of slides. And what we're going to do is, once we've been able to sketch the system, grab the water supply and the sprinkler head, we can really start to make a determination. And now, as if we're almost detectives, we're going to start to work with what we have to determine some design. So I think what I'll be doing is a monthly video, as I am retired, so I'm not going to work every day on this. And we'll come up with the next piece, which will be using bits of information to establish probable densities or acceptable sprinkler systems for occupancy. So I hope you enjoy, and I'll be talking to you next month. Bye now.